All right, welcome back to the third part of this series. So in the previous two, we loaded in the data set and we took a look at what is a model that exhibits high bias. What are the characteristics there? And so we see here the key takeaway with a high bias model is that not only are all of our models wrong, but they're consistently wrong in that for this particular row, they underguess, okay? So now let's kind of compare this to a model that exhibits high variance, and that is a decision tree. So I need to clean up my code a little bit here. So rather than just being a generic list of predictions, I want this to be dummy predictions so that we can kind of see how these compare to the model that has high variance. So changing the code here, we'll go dummy predictions, and then dummy to predictions there, rerun the cell, just make sure everything works. And then we'll look at the variance for those dummy predictions as well. Okay, so now we can throw in the tree predictions as well. So we'll do tree predictions. Will be an empty list. We'll make this, instead of being just a generic model, this will be the dummy. And so I need to make sure I change that there as well as there. And then tack on the prediction that way. Okay, so that all looks good. So now I can start just kind of copy and pasting code as long as I get it right. All right, so we'll have the X and Y all to itself. All right, so we do the dummy stuff. And so now we can kind of just take this bit of code here, copy and paste it, and as long as we get it right, hopefully we don't miss any variables here. So we're going to tree fit, pred is tree predict, and then we have tree predictions. Okay, so fingers crossed. Let's see if this actually works. So what I'm going to do is rearrange this matplotlib code so that we can get a histogram of now the dummies along with the trees. So we'll do tree predictions in here as well. And I'll make this green since, you know what, they're trees. All right, so dummies, I don't know, blue I guess is a good color for that because I can't think of anything better to do. Okay, so running the cell. Now we have 1,000 trees also making predictions. So this is a model that exhibits high variance, the decision tree. So notice the key difference here. All the trees are straddling the truth, right? So in the aggregate, they found the truth, which, by the way, this is a bagging regressor. So that can be another YouTube video down the road. But the essence here is that the trees collectively found the truth, okay? So the issue, though, the counter to this is that each tree overfits like crazy, okay? Decision trees, when left alone, will find every pattern, even though a pattern does not exist, right? So you and I are very similar to high variance models, right? We know that our favorite team is going to win the game for obviously because the stats are better than the other team, but also because, you know, sometimes we wear our lucky pair of underwear. And that's why our team wins. So we find signal where there is no signal, right? And that is kind of the key characteristic of a high variance model, one that overfits. So these trees clearly found the truth in the collective, but in the aggregate, they also found a lot of noise, and we're looking for patterns where no pattern actually exists, right? It's folks that chase the stock market by looking at a chart and sort of divining the direction that Apple is going to move today or tomorrow based on the pattern. So that's kind of a good example of like high variance model. And so as the name implies, it's the variance between the models. And so if we actually look at the variance of our trees versus the dummies, right? So if I do tree predictions here, you can see that on a relative scale, it's a couple of orders of magnitude, or what is that? One order of magnitude larger? And then double? I don't know. It's bigger than the dummies, right? So you can see that here. So the variance between the dummy models was 0.12, whereas the variance between the trees is 2.6. So clearly high variance, right? So we have models that have high bias. We have models that have high variance, okay? So what is the trade-off part that we're talking about here? The trade-off is as you increase in model complexity, okay? So obviously, the simplest model that is out there is the dummy, right? It just predicts the mean. So if you want to improve your model's performance, you need to make your model more complicated. And so you can do that by either adding more features or, in what we did here, choose a more complicated model. And so we did that with the decision tree. The counterpoint to that, though, is that as you increase in model complexity, you are likely to run into error due to variance, and that is your model is overfitting to its training data, okay? So in the next episode, what I want to do is kind of show you the Goldilocks model that's sort of in between the two, right? So we have more complexity than a dummy regressor, but less variance than a decision tree. And so what you're going to see in the next video series is that this trade-off is not a zero-sum game. So it's not like as I increase my model's complexity, it's not a one-for-one trade-off in bias versus variance. So we'll see that with the linear regression when we do the next video here.